Okay. Okay. Take the following down: applications, uses, importance. Anyone can go. Your name is Refila General, Refila Prefect. So you don't buy the book, Iba? So your life have changed, Abi. Go and read separation techniques. That first part. That's that's testing for purity. Read it. Boiling point. More. If you read that book, read that thing, you are sure of 6 questions coming out. No textbook explained it the way the book. I'm talking to those that are buying books. You that are not buying book. See books here. Okay. Applications of electrolysis. Number one. Number one. Number one. Extraction. 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 Extraction of metals. Extraction of metals from their ores. From their ores. Number two. Number two. Purification or refining. Purification or refining. Purification or refining of metals. Purification or refining of metals. Number three. Electroplating of objects or metal. Electroplating of objects or metal. Number four. Production of gases. Production of gases. And number five. Manufacture of caustic soda, in brackets sodium hydroxide. Manufacture of caustic soda, in brackets sodium hydroxide. Ozigo. What do you understand by the term metal? What is metal? I would like this class to be more of interactive. If I see Mike, I would have given to somebody. I can tell you, nobody will give me the definition of metal currently in this class. Nobody. I can tell you. I can tell you. Okay. Do you know what is a chemical substance? This zone. This is a noisy zone. I don't like noise. Alumni so noise making. Wawana yeku. Gaye kulugena, nkulugena yebekwaku. Oh, come on, John. Okay, now listen. Now, Now, when you're asked to define something, I'm telling those of you that are SSCE here, because WAEC will say defined. Defined means to say in a short form, summarize what you know about a subject matter. Summarize what you know about metal. You can summarize it in just few words. That is definition. If you just define something, I just give a peripheral of that particular item. You've not defined anything. And we in the marking center, they will always tell us that if so concepts is not covered in your definition, students, each feature that are not present in such kind of definitions, either you give the student 2 marks or you score the person 0. It's not a case whereby you are tried, you have said the first point, you are making a point, and at some point you deviated from making a point. You have lost every mark. It's not like classwork. Teacher will give you something to define, and you make attempt to define. You say, he tried. Instead of giving the candidates 2 marks, let me give 1 mark. WAEC is not like that. That's why people hardly make it, as in not making it by copying, make it on their own. That's why people don't find it difficult to make the exams. Because nobody has to get defined like he define. Like somebody will say, metals are elements that ionize by losing I think that's what all of you will say, but you will all score 0. If I'm to be an examiner, problem would be, because if you not say it the way I like it, the way it will move me to mark the exam, you need to trigger me that the definition met the requirements. I will not give it to you. I will just give 0. Yeah, you know, it's talking rubbish, PR 0. I'll just go to 0. But to mark 0 step is even fast. PR 0. PR 0. Fast. Before you know it, your hand will go like this. Sometimes we do work when we are marking. During that marking period, you see me working, I will do like this. Because I'll be marking, I'll finish my own, I'll collect another one, I'll mark. Because you're not making the point. That's why most of these chief examiner, they like me because I deliver. They like it when you mark something and you are marking good. You are not marking to impress. You're marking what is required. So what we're trying to tell, that's why you are here, to be informed. Once you are informed, you know this thing, you go there and do the right thing. If I want to define metal, I need to put some things into consideration. Enjoy defining. Oh, here check. Matter what to say. I do know very well that metals are one element. They are elements, Abi. They are one chemical substance. They are chemical substance. You know what they are chemical substance? They say something is a chemical substance. What does it mean? What does it mean? Is urine a chemical substance? Urine. You see the problem I have with you. If I'm to be a JAMB examiner, I will ask this question and you fail it. Urine is a chemical substance. You imagine. That means you don't know what is chemical substance. A chemical substance should not be a mixture now. A chemical substance must be a substance that has the same kind of particle. The particles are same kind. And for it to be same kind, the particular matter must be pure. That is why the way pure type of matter and what? Impure. The ones that are pure matter are called what? Are called element and compound. The ones that are not pure are called what? Mixtures. Is in this short guide. Is there? You get this it. You don't want to get informed. It's a book that gives you all of these things. You're supposed to be happy by now. I know you have it. You have it. Okay, we're getting. Listen. So, I need to understand what is metal. Metal. They are atoms. The atoms are the raw stable. Anyway, an unstable atom. Do you know what I mean to say that an atom is unstable? You know what I mean is unstable. I'm not talking about the nucleus. I have nothing to say about the nucleus. I'm not talking about radioactive. I'm not talking about nuclear reaction. I'm talking about ordinary chemical world reaction. Something can be unstable. by having to what? To lose electron, Abi, to be stable. Do you get the point now? Sodium is short one. Just short one of achieving stability. You know what I mean, short one? The atomic number is how many? Is it not 11? Hey now. It's very close to achieving neon stability, isn't it? By lose or gain. By what? By losing. That's why it's unstable. And that is why metals appear not to exist free in nature. Uncombined metals does not what? Exist in their free what? States. Hadro, you can never see sodium uncombined. It doesn't exist as what? Uncombined. You can never see aluminium exist as uncombined. You can't see calcium exist as what? Okay, money are uncombined. You know this, you know uncombined. Any other atom, they are just what? Alone. Because now atom here will easily ionize by losing its valence what? Electron. But even if we're gonna hydrogen also loses its valence what? Electron. Hydrogen that we lose like this metal. Is hydrogen a metal or non-metal? So when you are defining this thing, you will exclude hydrogen. Because hydrogen behave as this element listed here. As alkali metal and also as what? Alkaline earth metal. That is why hydrogen looks like it has this kind of anomalous behavior. Its behavior is so anomalous. Anomalous. Always so many discrepancies about that element. So many things to say about the element. So it does look like, in fact, it's not even supposed to be in group 1. Modern periodic table, remove it from group 1 and put it somewhere in the middle. But if they do it here, you start arguing. That's why I still use based on the old one. I put it in group 1. It's not supposed to be in group 1. Because elements in the same group will tend to show the same chemical what? Properties. That is how they're in the same group. What is hydrogen doing in group 1? Nothing. Is it an alkali metal? No. What is it doing there? It's not occupying space. Okay. Hello. Yes. Okay. So now listen. So since this element appears not to exist like this in nature, it means that they must have existed by losing their valence electron. So metals are elements whose atom ionize by losing their valence electron, with the exception of what? Hydrogen, to form a positively charged what? Ion. This is what they want you to define. If it is like this, you have your full mark. Their atom. Okay, say it again. Metals are elements. Metals are elements whose atom ionize, by loss of valence electron, ionized by loss of valence electron, with the exception of hydrogen. To form a positively charged ion called cation. What? Cation. Now that they have, you're not writing it too. Now that they have formed these cations, I want to use A typical example like what? What? Aluminium. I want to use this example. Aluminium. What is the primary ore of aluminium? It is what? Bauxite. Is it bauxite or bauxite? I think the spelling is correct. Is what? Bauxite. Under which classification of ore will you see bauxite? You know what I mean? Classification of ore. I will 6 main classes of ore. Okay, do you know what is ore? You don't know what is ore. If I tell you what ore means, you know you don't know. That's why I'm telling you, use this opportunity to collect this book. A lot of information that is there, you'll be marveled. If you buy this book, read the book. How many of you here attend Iga Secondary School? Iga Special Science Girls, Aban? How many of you got Aban Special Science? Unyakin. Okay. We can have a fellow. But we came, ma'am. I taught in that school for 10 years. Yes, 10 good years. I was with them for 10 good years. And that these girls, you know, these girls' schools, they have one culture. There's one thing I like those girls. They are very good in cramming. This set of girls can buy past question. If you are the type of teacher that sets exam from past question, they will make it. They are good, but I like it. There's one there, not just close to average, not up to average. He made a jam results maybe last 5 years ago, 300 and something. Just something that is not up to average. I asked her how, because I know he cannot reach 300. There will be some of these things are in the past question. You have anyone you say he'll give you the year, tell you the answer, but you don't know why the answer is the answer. So sometimes read like that. Read like that. Actually, if you are going through something over and over again, you get used to that. If you see it next time, you already know that this. Without even finishing it, say, I've seen it in 1 year. Look at the answer here. I don't even know why the answer is the answer, but I'm sure. You go for the answer. So the man name you because near your high mark, your opportunity to get it. You look for strategy. Yeah, strategy to pass. Let me tell you something. Exam now is for advantaged people. Advantaged people that money, your sponsor must be loaded because school now is not easy. And above all, you must have something here. And then you have something here. There are people that their brain is more hotter than your own. Then what will you use? Strategy. This strategy now, and I'm telling you, add it to the one you have. Make this thing your companion. Kiniana alusted. Understand? Kiniana alo. You see this couple of books. You know what I'm saying? Because I have identified some errors in some other this thing. I've been able to pinpoint it and make this thing very, 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 very nice. But see, I don't have time to talk about this thing. You are an adult. You know which is which. Hello. Omo. Okay. You have said your own now. Okay. Hello. Hello. Now, if you define ore as you are trying, some of you are telling me crude, okay? I heard somebody say crude. You say raw material. This is how you understand it. You are defining it. Don't say things you think that it is. You have to look at some kind of, okay, what is this thing? What is this thing? It's minerals or? Are they all? Are all mineral? But you say minerals are all. But now all are not mineral. I don't understand. Which one? Okay, he said what? He said what? He didn't know what he said. He said, now let me tell you. Kuno mota kuna mota yofuma. Oya taja gola oku ke mota. Wakan gwagi. Kan wagi yoku. Kan wagi nga wagi yoku ziketa. Iku imali yoku ida agwa akwo. Na mi wa choro yoku. Ibe bodi ya yo ni kulo. Gwagenti. Now, okay, for substance, natural substance that can be found free in the earth's surface or in the earth crusts are called what? Minerals. But they will eventually become ore if the mineral contains metal that you can extract. Are you with me? Open a mineral, it will anything metal anemia. It can be an ore. It can be an ore. But open away metal anemia, you can call it what? Ore. That's why I will not tell you this now for free. That all ores are what? Minerals. But not all minerals are what? Ore. 3 points. Look at it. 2. No, need to quick it up. Anyway, clay. Clay. Clay is what? Is a mineral. I mean, but you know it contains complex silicates of aluminium. That is clay. But you know, even aluminium anemia. But because you cannot extract aluminium, there is no sophisticated machine that can isolate and extract aluminium from clay. Because the amount of aluminium in clay is too minimal. So there is no machine that can bring out aluminium from clay. You can only refer to clay as what? As mineral, not what? Ore. It is this one you can call mineral and the same time called what? Ore. Do you understand? So that's all. And then for the fact that because metals condition hano, but hano as hano zota, hano zota. If you like it, because they are unstable. This is when they are not stable. All of these now are having stable number of electrons. Like hand checking of this number of this thing has completely filled orbital. Now that they are electropositive, they can easily combine with electronegative elements within their environment. How we can combine with silicates? How we can combine with chlorides? How we can combine with oxides? How we can combine with carbonates? How we can combine with what? Sulfate, sulfide at the same time. When they combine together with impurities now, it now will be referred to as what? Ore. It becomes ore. That is how metals exist. They exist in crude form called what? Ore. Ore are compound of metal with earthly impurities. Are you with me? Can you work it out? Compound of metals with what? Earthly impurities. Look at why it says so. Look at why it says so. You know that this bauxite now. Then this bauxite I know. This bauxite, which class of ore is this bauxite? As a class of ore, bauxite. Bauxite is what? An oxide what? Ore. It's an oxide ore. Are you with me? What is the formula of bauxite? Let's check. What's the formula of bauxite? Al2O3 dots 2H2O. Mbalanjo marikita ya bolo mo this thing na boro ya nisika afi here the board. If you go near the moon, it's common say, that means the salt is hydrated. It's only a hydrated aluminium oxide. It's another name for what? Bauxite. I come back. A piece of paper. what you say. I've not seen anything, I think. I don't know. Is it how we behave to other teachers? Am I the only one that's you? I don't understand. I'll make sure this kind of thing is not recognized here. If you want to, sir, please, I don't understand. What? You don't understand what? If you don't understand, is it my problem? It's your problem. I mean, I gave you a couple of applications of electrolysis. I deviated to metals because I needed you to have the background. I know that somebody is taking your metal already. I think one class like that. I just deviated metal. Come metal, so that if I bring you back to extraction, you will understand my point. Somebody is here, right? I don't understand. If you don't understand, that means you're not supposed to be here. Find where you are useful. Come here and be occupying space here. Don't know anything. Okay, we can be here now. I wish I had much of an idea. Perfect. Nabia will tally. Okay, now listen. All the very simple. All the very simple. Or less money that go. If you ask me, Jambi is very, very near now. Jambi logo. A big amount of Jambi logo so. February go now. Imagine. If we say days, I was also. Obu na topic in a good believe. If we say nigga was under pressure, that's the worst thing that can happen to you. But now is the time. Get this ground. Get this thing known. Nanyaba. You watch if one that this aluminium, are free. Combined state here, this bauxite is what? Oxygen. This is the main radical of this particular aluminium. So the class of this ore is what? Oxide. There are so many other ores that are oxide apart from bauxite. Which of the following ores or all the following ores are oxide except aluminum oxide. We got oxide. If oxide. No, they will give you what? Bauxite. If you do not know the formula of bauxite, that is your business. They will simply give you another option. Option B, hematite. They will give you hematite. You see, they are using the common names. They will not give you that hematite. What is hematite? But all of them there you pack name. Hematite. Hematite. Ah, see. Huh? Do you know those come on that goes kwa zero na uko? Iron 2 kwa. Take us iron 3 un tell me Fe2 ogene. Is it not O2? O3, correct. That is hematite. Is that an oxide ore? Yes. Then there are too many. I can give you on our magnetites. Another one. What? Magnetites. This one is a dangerous iron oxide. And iron 2 iron 3 oxide. It is a mixed oxide. Mixed oxide. You will take this one. Mix here with this one. You mix here now. Mix here Fe with this. Fe what? 3. What? 4. This is the formula of magnetite. What type of oxide is magnetite? Mixed oxide or higher oxide. Corundum. So give me corundum. Corundum is another name for alumina. What is the formula of alumina? Al2O what? 3. Alumina. These are a class of what? Oxide ores. I think which of the following is not? In option A, option B, option C. You see the answer is oxide. They will call it what? Corundum. Very strange. They will not call alumina because they believe some of you know alumina. But you know that alumina is same, can be used interchangeably as what? Corundum. Corundum. I bet you say D. Galena. Which one is not oxide ore there? D. What is galena? PB what? S. Let 2 what? Sulfide. Is that an oxide ore? Which ore? Sulfide. Is calcitrites an oxide ore? You don't make calcitrites. Only name for calcitrite is what? Tin stone. What is the formula of tin stone? SnO what? 2. That is tin 4 what? Oxide. It's an oxide ore. It's an oxide ore. There's another one we call iron pyrites. Iron, keep my iron. There's another ore of iron. Which class of ore can we classify iron pyrites? It's sulfide, because the formula of that is what? FeS what? 2. The common name of this is called fool's gold. It's a gold for the fools, because it look like gold. Fool. Fools. Gold. Which of the following ore is referred as fool's gold? On a yellow, and on a brilliant yellow solid. If there is no difference between gold, real gold, and this gold. So people that this thing has been used to deceived, that they fall prey to this, thinking that this is gold, they have been fooled. So many people have been fooled because of this. People think that this is gold. Why is not gold? So it's from there people have been fooled to believe that this is gold. Why it's not gold? From there, the common name of this. In fact, the name of this now, this fool's gold, is name that can easily be used to recognize this word, iron pyrite, which by IUPAC name, it is called what? Iron persulfide. It might be iron 2. Because sulfur here is minus what? 1. Sulfur and oxygen are the same group. So oxygen gets form minus 2 in combine minus 1. Some sulfurs form compounds with heavy metals in the state of what? Minus what? 1. So this is pair. Normally here we say Fe what? S. Which means that sulfur here is minus 2, abi? Iron here is what? Plus 2. What do you call this? Iron 2 sulfide. It just say we say extra 2 here. That means it's no longer 2. Opposite 2, man, opposite sum of these 2 will be more than 0, isn't it? So you're opposite it, that means instead of minus 1, instead of minus 2, it have minus 1, so you can reconcile. So it means there is additional sulfur in this compound. That's if you want to name it, so iron 2 persulfide. But what is that iron 2? He said you call it iron pyrites or what? Fool's what? Gold. All these are class of what? Ores. And ores will not only contain compounds of that metal, it will also come with impurities. You know, we just mentioned give the compound. Like something like bauxite now. You know, bauxite also has some impurities that are inside. That is inside. This examiner will want to ask you, exploit you. Try to know if you are thick in that area. They want to know if you know that this bauxite will not only be compound of this metal, there are some other impurities. Because when you define ore, you say that ores are minerals that contains compound of that metal with earthly impurities. That earthly impurities. Like if you come to ore, one of the impurities in this bauxite is what? Silicates. Silicate is the same word we use for sand. For what? Sand. Okay, my aja. Aja was silicate. What's the formula of aja? The real formula of aja. Sand. SiO what? 2 or SiO 3 what? Minus. Whichever way to give silicon 4, you are correct. What is this one? Silicon 4 what? Oxide. What is this one? Trioxosilicate what? 4. Both of them are what? Sand. Hey! So please, bauxite in the past question, I saw is LOCOH3. If you saw it like this, please go and throw away that thing. You know, this guy has been, see, see, some people, what you see in the textbook, you so much believe in the textbook than the person standing before you telling you something. Suppose I say something that goes contrary to your textbook, you argue with me. I will even try to explain. You bring textbook as if what is the textbook? I see it in the textbook. Will still be that the textbook will always be correct. Yeah, it's not the person that wrote the textbook. What if the person during the process of typing and there's a typographic error there, and then they bring it like that and you start seeing it, and you come here to argue with me? I've told you it's this thing. You're telling me it's ALC. Nah, man. I think this thing is chemistry quantum forbidding. It's forbidden. This is no correlation. This thing can never happen. See the formula. The formula even look like a word. It's like a word I don't know how to pronounce. ALCOH3. It looks like alcohol. It's the formula. And this guy that wrote this thing, you must be under the influence of alcohol to write. You can have alcohol on it. Don't worry. Next week I will teach alcohol. Please make sure you're in that class. And people that like this topic, alcohol. You learn so many things in alcohol topic as a topic. Some of your textbooks call it alcohol. It should be alcohol. Alcohol is an example of what? Alcohol. Even alkenols. Even alkynols. Is it because of single bond? Was it alkanol? What do you talk about? See, you know what I mean? This is supposed to expatiate. Look at the dilemma. Look at. I need to say this thing somewhere. Even looking at it, aluminum carbonate does not even exist. You see, aluminum carbonate, it does not exist. I know the reason why. The reason is in that my book. I know to market my book again. I market my book. Okay, now let's come to extraction now. Let's now bring it to extraction. That first application, extraction of metal. At least you want to go background. Why you extract? You must extract. If you must need to isolate the metal from their compound or their ore, you must do what? Extract. And even extraction, there are so many metallurgical processes there. Extraction is not just like to. Do you know that? You know what it will take you to bring out this aluminum from this? It's not easy. To bring out aluminum from bauxite, it's not easy. It's not easy. It's not what? Easy. Because can we get the name of bauxite? One is what? Al2O what? 3. Manimia. How to go to water? Because water we command is insignificant. The other one, the beginning, Fe2O3. You do know it's also contains hematite inside it. That's why if you have seen bauxite before, I know you've not seen bauxite, but if you have seen bauxite is a solid reddish raw material. One actual red. Have you ever seen where they are digging the ground? And they one. We begin with the reddish sand. Do you know why the sand appears to be reddish there? Sand of money for red, it might not contain traces of what? Iron 3. You know it's second most abundant metals on earth, Abby. It is after aluminium. You see it almost everywhere. Understand? In fact, most reason why some sands are red is because of what? Iron 3 oxide. And then if you see bauxite, it is as reddish as iron 3 oxide. So you need to deal with how to remove those impurities and how to remove SiO2 as well. Process of trying to remove this and making sure that what stays in this mixture is only this. What do you call that process? Of removing some things, impurities from an ore and making sure that the metal compound you want to extract is the only one remaining. What do you call the process? Concentration of the ore. Concentration of the what? Ore. You know what is concentration? By the time you remove something you want to remove it, you now make that particular metal compound to be much in the mixture. That is called concentration, or you can call it refining. Or I can call it what? Purification of what? Ore. You make it very purified. That is the first step taken before extraction. Before what? Extraction. Because if you're extracting and there is any traces of impurity, though impurity is also good, though, impurity also help, but not this type of impurity. And this impurity will help to lower the melting point of the metal compound. Because it does look like the melting point of aluminum is so high that if you allow that process to go at that temperature, two things will involve. What are the two things will be involved? One, is that there will be costs of electricity. It will consume much electricity. Because in every electrolysis process, you use what? Electricity. Because you are using electrolytic what? Cell. I think I told you. You just got a cell, look at what you know, it's also electricity. Connect a cathode and what? Anode. You supply electricity to the system. Because the electrolyte will use electricity to work. You must supply. So you can imagine what it will take to supply the cell with up to 1,000 plus melting point of this with electricity. It will cost all the electricity. That is why, when I see people that hawk these people that do ice block, I don't know, you know ice block. Sometimes there was a day I saw one ice block producer. You tie ice block in the morning of 7, 8 o'clock. By next 2 hours, the whole ice block is already conk, as in that water is already blocked in less than 2 hours. You know that big what do you call it, freezer, and it needs 2 horsepower. Even with that, how many horsepower? It's not supposed to freeze at that short period of time. They need to be selling. So what they do, ask the woman, what did you do to hasten the process of freezing? They say they add salt. You see, when you are going to yoma, na go to school. Oh my yoga me, go wiki lafia. Go out to go help your man see game. Give wiki maoko. The woo is fully woo. See, everything is strategy. Life is strategy. Strategize. There's no way. If you know you are reading like this, it's not working. Find a strategy that you used to be reading so it will be working. The woman have not checked. You do know how much money that woman will make for waiting for such period of time. It doesn't look like the woman knows what you should know. Nobody thought. I said, who taught you that you had this thing, do this? He said, no, they find out it will work. And keep working. They add salt. It's not salt. It's to pay one salt. They go 100 naira. So that was when I now said, hey, it doesn't look like this woman knows that impurity lowers what? Freezing what? Points. Hey! No, yeah, come here. Go block us. So, but to choose the game later. Wow, that thing block, you will now sell those blocks. No, Cecilia. Now the block is now solid. It does not know that the impurity in that ice block, when it's now solid, will also lower the words melting point. When I'm going to say, Pia, before 12 o'clock, you didn't know go to Yamanchoi. Like, when you're Nikita, we come to go. Then jump on this area. You will see this kind of thing names around you. Now, and you'll be feeling. You need to be thinking, you need to be breaking an idea. You need to be finding a way to think this thing out. And then in this area, the choir house can watch. Imagukita. Just like in that short guide, it was described itself. It was there. It's there now. Go and check it. You just buy a seat. Listen, can go. Say now for that now. If impurity lowers, melting points, then for you to save that electricity, just like that pure water woman, that block woman is saving his own, because him going get you made that thing called block in less than 1 hour block ago. Then when they make this thing, because him cut the woman marauko, because him imagine just something the bauxite that who take the bauxite so that this bauxite melt at that high temperature. The bauxite will melt at a lower what? Temperature. The person will now start looking for molten cryolite to put there. And then tomorrow, Jam will ask you this thing. It will look like you have not seen it before. Why are you adding cryolite in this extraction of aluminium? You add cryolite to do what? Lower or reduce or bring down the cost of electricity or lower the what? Melting point. Period. But if you want to now know further, want to now go further, you now see in that particular jam pack, they relate this thing with question they asked so how they think recently. You know, in some countries that are experiencing winter, you know where they have ices on the what? On the road. You know, they have ices in that period. You see some people that are Iswama people that are wearing those aprons, they come very early in the morning to clear the road for people that will start going to work by 7 o'clock. What they do, they start to sprinkle sodium what? Chloride or salts on this what? Block. Why would they sprinkle salt there? Because before 7 o'clock, nobody can go all, so that those whitish icy substance will do what? Disappear. Because why is it disappearing? Because that salt added to that icy road had what? Reduced or lowered the what? Melting points. But later they discover that sodium chloride had a use at the good. I find out that now, in fact, sodium chloride had a use before has run out of disfavor. Okay, about disfavor. Or those favored to be used. Because they discover, you know, they know something. They discover that if they use that sodium chloride to sprinkle on the icy road, they find out that their engine or some metal part around, because all the vapors around, heat as a because of the low temperature where bank block. Every substance around the market will start to block. Motor will start to block. And the motor contain metal parts, aluminium. Okay? Some of them are built with what? Lead. Some of them are built with what? Iron, alloys. Get the point? And then chlorine, chloride, they're very, very wicked. That chlorine, most metals react with what? Chlorine. If you get that. Then if they find that using that particular sodium to sprinkle on the icy road, now chlorine, GC, help your galo, you lower the melting point. Just now react with the metal part of their vehicles. Then or react with the iron. No iron. Or react and form one iron 2, which is not stable. After some time, iron 2 oxidized to what? Iron 3. Sodium chloride. Now, they ran out of that one. I found that this one is no longer good. They find that there is some kind of something that is pseudo salt in nature. It's not a salt, but it just behaves like salt. This is why they now look for what? This substance called what? Called what? Glycol. Who did glycol? Those engines, those metal parts. In place of sodium chloride they were using to sprinkle, they are now using this what? Glycol instead of what? Sodium chloride. Tomorrow, Jam will now ask you, why does this one, the former one, run into this favor? And why are they using this one? You now see the fact that the sodium chloride is attacking some metal parts of those roads, those vehicles on the road. The metal part is the chlorine is oxidizing the what? The iron. And once iron deoxidizes, it's now rusting immediately. Once it is iron 2, where is it? Iron 2, iron 2. Iron 3. What is iron 3? What's the color of that engine again? It starts to turn to what? Reddish brown. And reddish brown is corrosion or what? Rusting. What time is that? They will go in there. And you know this thing has been very, very useful for them. They've been using this thing very well. They use it as antifreeze in their car. Okay, antifreeze. Not in Nigeria. There's nothing that can make you here driving your vehicle here. You're driving your vehicle, and the water you pour in the radiator will not start to freeze. That's not possible. And the water in the radiator will steam. If you're not careful, if you come close to it, it will even deal with you. Okay, I'm in the way motor. You know what I mean? Check your motor kita. But a long distance, but the parasitic phone, the water they can now boil in Nigeria. But their own the temperature they have very low. Now I made the millet and I block. Or block was here. Or manage the people to see millet to the some cooling system Nigeria. So you have the best. How when you bring the radiator, he mix here some small sample of glycol. So that if eventually that the water may cause it freeze, gonna freeze, gonna get a melt. That is why this is used as what? Anti-what? Freeze in car what? Radiator. About Nigeria. So Keta, how use again? I forgot Keta not very useful. They now have suspended sodium chloride. They are now using glycol as what? As salt. They sprinkle on the icy road to what? To reduce the what? Melting point of those ice. So you icy road with snow. Snow. You don't know what to snow. You don't know what to do. Don't know what to do. Snow. You don't know what to do. Salt. Go to salt very well. Salt just everywhere. By inside under 15 minutes, the whole thing is cleared. Yes. Why not? What is glycol? Okay, what is glycol? If you treat negative, if you treat alkenes, alkenes are carbon double bond, isn't it? And it's organic compound whose priority functional group is what? Double bond. But I'm going to talk an exam. What is the functional group of alkane? It's not double bond. You got to hear. Because double bond can exist in so many places. What's the kind of double bond? Carbon, carbon. Double bond. It's zero carbon, carbon. If you treat this thing now, this is what? This is what? We are geometric because no, we don't know atom. We don't know so many atoms. What will become the other side. So it cannot be asymmetric. So it cannot be. You can't be any geometry, even though it has multiple double bonds, but it cannot show any clear case of geometric isomerism. I mean, so there's no geometric isomerism here. What is this? 18. Anytime you see a chemical bond, you see a single bond, you call a single bond a sigma bond. A what? A sigma bond. What do you call the second bond? Pi bond. Between a sigma bond and pi bond, which one is weaker? It's a pi bond. Do you know why pi bond is weaker than the sigma bond? You can't do the mechanism. Hybridization. I don't have time to talk about this. I just want to show you something. But you know, you watch your sigma bond. Yeah, but couple 1s2, 2s2, 2p2, MHMA 2s1, 2p3. If you hear me now, if you that now, in this particular one, here we have sp2 because I'm going now. So in watch if you sp2 now, s is 1. If you s no nime, if you s akita, all nime, as this second one kita, this is 1, 2. Orbital K2s are not nime. So before you will see this S, you must meet this electron here. So that's why before you went to Nyenka, you want to go to Guinea pi bond. So if you are attacking, if you are adding any reagent on any unsaturated hydrocarbon, the particular group that will be attacked is the pi bond. Are you with me? Is a pi bond or double bond. That is why alkanes are chemically what? Inert. Alkanes. You know they have how many bonds there? Single bond. You cannot attack a sigma bond. That's why alkanes are not reactive. The only reaction how we can manage react here is what? Substitution. You cannot come and attack their bond, but you can attack this bond. So if you now treat potassium permanganate, KMNO4, if you treat KMNO4 with alkaline solution of sodium hydroxide, you have Bayer's reagents. Abi, you treat here, then a reaction called hydroxylation reaction will take place. Do you know what is hydroxylation reaction? It is whereby this particular KMNO4 will give peroxide, HO to this bond. Imagine this bond with one electron. So this one has one electron free. So they will share. And by the time you see that, you see this thing becoming like this. This is how it was before. Bond that get shipped to the Korean opportunity in the now. So here I was it H. And that's it from one year, but it's as what? OH and what? OH. Do you get the point now? Normally for alcohol, look to hydroxy group on the adjacent carbon. Okay, for all the adjacent. Imagine adjacent carbon. Carbon no doing so. This side by side. Open here with 3. 1, 2. Obewe OH eba. OH eba. Is this an adjacent carbon? It's not. Obey 3. Obewe OH here. Where OH here. Is it adjacent? For you to call it adjacent, the two must be what? Close. Open an OH eba now. What will you call this? You call it what? You call this thing what? This one will come from propane. This one will come from propane. This one came from what? Ethane. If you like it. So since this one is coming from propane, and the old name of propane is propylene. So you call this a propylene glycol. That you mean now. Since this one is coming from what? Ethane. What will you call this one? Gini? How about nanka? OH deba. Other zeba. You got one nka glycol. Before you put OH glycol, the OH, the 2 hydroxy group must be on the 2 adjacent what? Carbon. But somebody just say, easy fear. Glycol keji Maria in the bow. Eji Maria kitabu. Gini, after kitabu gini, ethane. But you will not omit E. You can only omit E if the OH is only one side. A water OH, not monohydric alcohol. You can call it what? Ethanol. If I get that. But since it has 2 OH, you must retain that word E. It then becomes ethane 1, 1, 2. Ethane 1, comma 2. What? Diol. Ethane 1, 2 diol is same thing as what? Ethylene glycol. Are you with me? What happened from here to here? The reaction of ethane with this KMNO4 treated with sodium hydroxide called Bayer's reagent is called hydroxylation reaction. Hydroxylation. Maybe hydroxylation. Adding of what? Hydroxy what? Group. It's not hydroxy group added to the carbon. It's not hydroxy group. If you're adding hydrogen in the group, what will you call it? Hydrogen. If you're adding halogen, what will you call it? Then if you're adding, what will you call it? Hydroxylation. Which reaction give a glycol from treating ethane with Bayer's reagent? Which reaction is it called? Hydroxylation. Which reagent is used to treat? The process of treating, the process of chemical reaction of treating ethane with alkaline solution of KMNO4. If you get that, even alkaline called it will go acidic one. They just treat it with what? Sodium hydroxide. It will now become alkaline. If you get now, what was the alkaline solution now? Okay? Then you want alkaline to OH can donate now. Abi? You know what God does of me. For no OH can the KMNO4 can now like he walk with. Open no acid, mono can work with what? With hydrogen. Are you with me now? So the polar form when 18 is treated with alkaline solution of purple potassium tetraoxomanganese 7. You see the point? You know, as I say, this thing is treated. That's why we're taking double what? Hydroxy group from NOH. So that it will not attack the what? The pipe. It attack what? The pipe bond. Attack the pipe bond. That's the best thing to say. Attack the pipe bond. Or attack the pipe bond. Which product is formed? Ethane 1, 2 diol, which is a glycol. Because the glycol, there is so many types of glycol. But the glycol is specifically coming from ethanol, from ethene. If you like it, what type of glycol is this now? It is now called what? Ethylene glycol. Because we have different kinds of glycol. What if it is propane you are treating with this kind of reagent? It will still give you a glycol. But since it's coming from what? From propene, you now call that one what? Propylene glycol. Glycol is now used as salt now that replaces chloride to now sprinkle on icy road where there's what? Winter. If you sprinkle, it will still lower the what? The freezing point without attacking some metallic what? Parts. Because we no ions. But now sodium chloride will ions. More you are aware, maybe eyes are hydrolyzed here the salt. Again, NaCl. Again, Na plus what? Cl minus. Cl again an ion of the engine. If you react with the ion, To form what? FeCl what? 2. Which oxidizes what? FeCl what? 3. Oxygen is not the only metal, only substance that can cause rusting. Chlorine can also cause what? Rusting of iron. Rusting can cause by what? Oxygen or what? Chlorine. Any oxidizing agent can cause rusting. Chlorine is what? Oxidizing agent. Just like what? Just like what? Oxygen. Somebody will write something now and say me, I don't understand. Check and back. So let's look at that extraction now. Now listen to me. Extraction of metals from their ore by what? Electrolysis. Which metal can you extract by electrolysis from the ore? What metal can you extract? Metals you can extract by electrolysis is what? One. One is what? Sodium. Sodium metal. Sodium metal. What is the chief ore? Many ores. Will a particular metal with one major ore? Ore na too many. Come on, it was in can choose to see very important. So what is the chief ore of sodium metal? Chief ore is what? Is what? Rock salt. Rock salt. By the time you purify rock salt, it now becomes brine. But to talk about rock salt, it can contain impurities. Because it water is seawater. Or contain calcium. Or contain magnesium. These two ions now cause hardness. Which animate this rock salt. So before you call it brine, you must what? Concentrate it. And if you must concentrate it, you look for something that will precipitate the impurities from the ore. Which will precipitate the impurities from the ore. You look for something like this. If you bring it out immediately, why will you use this thing to bring out some of this or some of the ions here, like calcium and magnesium? Why will you use this? It will precipitate because this carbonate of this, when it precipitates, is insoluble. See? This too is also what? Insoluble. By that, you can at this point, having mixed these two together, this will be precipitated from the mixture. How will you now remove this from the mixture? Filtration. Are you with me now? Why if it as a raketa? You guys na rock salt can pure sodium what? Chloride, which you can now call what? Brine. If boy a brine was a problem. My joke, what is the ore of aluminium? It's not alumina. You have a problem. The ore of aluminium is what? Bauxite. But it's not bauxite we use later. What we use after purification is what? Is what? Is what? Alumina. Alumina is the concentrated bauxite. Just like rock salt is what? Rock salt is ore of sodium. But during the process of electrolysis now, if I want to start the extraction of sodium now, what I will use as electrolyte is what? Is what? Brine. I'll put brine in down cell. You know what? I'll put brine in what? Down cell. And the metals, the reason why you extract sodium metal by electrolysis is because of what? Reactivity. Yeah? Oh, they're very reactive. It's very reactive in the sense that if you try to use reducing agents like carbon, okay, or what? Hydrogen, or you can use carbon as what? As what? As what? Coke. This metal they hide and cook in the what? Reactivity what? Series. This metal they hide and what? Hydrogen. So you cannot use chemical what? Reduction. You cannot use chemical what? Reduction to extract it. You cannot also use high heat, immeasurable heat. You cannot use heat. And to give me, you might use heat to decompose this so you cannot have sodium and chlorine. Why is this? Why is heat not used in the electrolytic reduction of sodium from sodium chloride. Why are you not using heat? But there are three methods of extraction of beta. Three. One is electrolysis. Two is chemical reduction if you're using any of this. Then three is heat or thermal. But why are you choosing to use electrolysis? Why are you not using heat in the electrolysis of this sodium chloride from brine? Why? Which can react? Asking why is it not using heat? Why are you not using heat? You can ask him now because now the salt is very stable on heating. All is stable on heating. Something is very stable. No matter what you heat from now till tomorrow, it will not what? Decompose. Heat, come on, get melt. But when you get back, go dissociate itself. You cannot do that. That is why you cannot use that method. The reason why you cannot also use the second method is because sodium metal you want to extract is much higher than the what? Reducing agent that can reduce them. So you cannot use that process. So the only process that is left to extract sodium from it ore is what? Electrolysis. There are 5 metals you do so, like that. Next metal is what? Is what? Potassium. Next metal is what? Calcium. Next metal is what? Magnesium. And the last metal is what? Aluminium. Take note of these 5 elements. Find out strategy to know them. Sometimes you find out some kind of acronym to remember. That's strategies of reading. I should not be teaching you how to read. If you want me to teach you how to read, come and meet me. Okay. Okay. Now that you know these metals, you know this is not the metals, the ore metals that we have in the series. After aluminum, the next metal is what? Is zinc. But after aluminum, if I give you the reactivity series now, the ones that are very, very common for your level, I will start with sodium, potassium, calcium, sodium, magnesium, aluminium, carbon, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, and what? Gold. When you guys say, hey, what the was on the can't see them and can't ever. Oh, there go. Hey, wag. Hey, wag. Hey! Carbon, I think to come on my own. I couldn't call him carbon. You only take carbon ever. Of course, he may tell it himself. Lithium possible number 1. But why I'm not putting lithium is not for your level. It's for your level. Next now, find out a way to know these metals at these points. Know that any metal that is above any metal that is above carbon. Carbon can this schema not carbon here. It's not cobalt. Only guy check it, it's not cobalt. They're in full. Any metal that you see that is above carbon, you cannot extract it by using carbon in form of coke. You see now, you cannot also reduce it by heating. So the only method left is what? Electrolysis. So can there from here to here, you extract by what? Electrolysis. Chicken. Why? You get you extract. And if you get you extract here, open at the salt of zinc. Yeah, zinc. Give me here. Is what? What is the ore of zinc? What is the ore? What is the chief ore of zinc? Zinc blend. Zinc what? Blend. What is the formula of zinc blend? Give me here. Zinc sulfide is a sulfide ore. But why am I not using this one? I'm using this one. As I'm talking to you now, maybe tomorrow, for now, there is no technology that can extract metal from a sulfide ore. There is no technology that you can use to extract a metal from sulfur. There's an ore that has what? Sulfur. If you get that. So now, you now have to look for a technique to concentrate this sulfide by changing it towards oxide. The process of changing this man to this man is what we call what? What we call what? Roasting in the world. We just carry this sulfide. Hey, there's no space on this board again. I don't have energy now. Luis, please, pity me. Please, let me write any space I see. I have zinc sulfide. What I need to do is to hit this zinc sulfide in the presence of what? Oxygen. So that now zinc kita puta or combine now with O, ZNO. So to protect it now, or pour now with O, pour as what? Gas. Or pour as what? SO2. More put as SO2, I cannot hear. Gas, zinc oxide. What do you call this equation reaction? What do you call it? Roasting in the what? Roasting in the air. It convert a sulfide ore to what? Oxide ore. Why megoliakita? No need gauges where measure extraction. You put zinc oxide akita. When you see enough coke, the coke is a reducing what? Agent. How put akita? Or now look at oxygen because not carry zinc. Activity. Nenya, yana zinc is above zinc, abi? So it means that it can displace what? Zinc. What displace zinc now? Or maybe we are oxidized to what? CO. In that process, zinc is what? Extracted. You do not need to use electrolysis to extract zinc. Why? Because it's lower than what? Carbon. Method you use to extract zinc is what? Chemical reduction. Using what? Reducing what? Agents. That's why. He said what? Hey, okay. If you're not smart in this world, you will die. My ear want to fall from this. What reactivity? Reactivity are the my reactivity we criteria who put here. Criteria does the best thing is electrochemical series. Why would calcium displace sodium? Calcium is a powerful reason. Calcium can weigh more. Never now. Calcium, in terms of reactivity, reaction with water, sodium care. That is what is called reactivity series. Are you with me now? But in terms of conductivity, calcium casia. And the chemical series is based on conductivity. Conductivity of the metal. Can you conduct also? Electricity. Conductivity increases across the period. If we look at that, conductivity, BMH selected this criteria. But overall reactivity, reaction with milli, sodium and potassium react vigorously with cold water. Calcium reacts slowly. If I'm not in back here, I'm not near no calcium now, no problem now. If you get that. No, can cause the looking now. Can cause the gaka. Do you know what will happen in the electrolysis of sodium from brine? Remember Kenya the cell down cell lower the melting point. The melting point of sodium chloride which is 900. Sorry, 801. Bioge in your melt or the high. But if you add calculated amount of this thing, what's this? Calcium chloride. It lowers the point from 801 to what? To 600. It is in that short guide. What did they? Actually, but exactly this equal to. But they even quote it for you. If you know, if you range, you can see 801 and 600 in the world difference. That difference can save thousands of what? Thousands of what? Dollars to achieve this 801. Now you are achieving it by just adding calculated amount of calcium chloride. Now you have added it now. The electrolyte now contain sodium and what? Calcium. If you remember that. So, what do contain more than that means we got two competing ions. But between this and this, which one will go to cathode? Is it sodium or calcium? Even in our body now, it is decreasing, isn't it? So the lower we got sodium. Is not sodium you want to extract? It's sodium you want to extract, have you? It's not sodium you want to extract. If you want to extract sodium, why are you adding something that will go instead of that metal? If you have if the way you thought, if you are thinking, this one is here, this one is here, that means if you put calcium here and put sodium here, it means that calcium. And calcium can say, how will you now extract sodium? Receive sense. But even though use go these two methods, use go the method herself, or no method dan, can both chia make use, care the textbook. My boss go to textbook, go textbook, or good no kaki use, still, kega when me again, still, kega sodium. But I come and keep saying, bo calcium, because of what? But in about now, the discharge is increasing. So you could say now I'm calcium, but this one is going. Remember, I told you in that cell you put calculated amount, small amount of this. So between this and this, which one is more in concentration? Sodium chloride. I told you that concentration can what? Can say so neighbor. The concentration can inhibit. Do you know what is inhibiting? You know what is inhibit? Inhibit means can stop position of the ion. You watch, I can put that like the two ions, which one is more concentrated here? Sodium can get in to what? To increase impurity. Which one is more concentrated in the solution? Sodium. Which one is discharged? Sodium. Why is sodium discharged? Based on your old pattern. Why is sodium discharged instead of calcium? You tell the examiner because sodium is discharged because of concentration. And the two ions are what? Are close to each word other. Are you following? Are you following? That's all like that. There is no electrolysis reaction, or there is no extraction of metal reaction that you will not add an impurity. Okay? Because if you do not add impurity, let me tell you what to do. Apart from saving cost of electricity, what you are doing now, it does look like at that temperature that sodium chloride will melt. Can we not 801 come melt? Haman joking the temperature will melt. So don't fear. Nobody will ask the temperature that sodium need to melt in the down cell. Doesn't matter, this solid, we heat here, or turn out again, NaCl. What's this? What's this? Liquid. More or liquid, marking up, again. Molten. Molten, what again? Fused. At which temperature can Hana Abuju me hame now? At 801. Then someone need to be careful. If you are running this thing in the metallurgical store or in metallurgical company, if you're not careful, this temperature, you want to gafe or by 802. What do you think will happen to this? It will no longer be liquid again. It now change the word gas. That means the two of them can only coexist at 801. And the main mistake, one arm panye, one Japanese. You might foresee this thing again. You know when it is gas, it becomes very difficult for you to trap it again. Because it will no longer be part of the system. It will go to the surrounding. Why? You don't need to maintain that temperature. So you look for something that will lower it. We melt. In that liquid that no 800. You still maintain that liquid at that lower temperature than temperature that will be mistaken, and before you know it, it turns to what? Gas. And then it becomes so difficult for you to what? Extract. That's why you're keeping it low as what? possible. That's why you are adding what? Impurity. What kind of impurity are you adding in that extraction of sodium? Calcium what? Chloride. Not fluoride, chloride. Can you add calcium chloride? You add something. There is a check there now. Even in a startable sodium and all sodium chloride. You need something you add that will have common ion what? Effects. You shouldn't go and use fluoride here. You need something that have common ion effect. And something not too close to sodium. Don't use calcium chloride to add, potassium chloride as impurity. Because if you use it, it means that the two of them, they are not close to each other. You use something that look to be very close. So no matter what happens, sodium will be what? Discharged based on concentration. And the sort of chloride choosing to use is because the ore is a chloride. So you need a common ion what? Effect. Called easy. When you increase the concentration of chlorine, in the calcium chloride, chlorine concentration to increase, thereby making chlorine to discharge, to deposit at a very faster rate to the what? Anode, leaving behind sodium. Because during the process, two of them can recombine. But since you have more concentration of chlorine will be first discharged. Because sodium had much in concentration. Because it's going to something that we utter concentration of chlorine already. So they make chlorine and decompose those fast to cut anode, leaving sodium to now find his what? Fate. You need to know these things, internalize it, so that anyhow question comes out, you'll be able to answer it. That's it. This one, nobody's giving me something to this. Maybe at the end, I don't like the maturity. There's somebody have given me, see this place, this is very clean. Have given me all the kind of people. I think those people that used to write those things, they are not in lesson today. Maybe they are still in the past. They are still in the past. When people still in the past, where they think that Mondays are not only for work again. They see this at home. Thank God they are not here. The next Mondays I will be here, I'll tell them that I think it's only two write-offs, two foolish write-offs I've listened to. That there are not how many write-offs. I can imagine this place is very neat. Bombard. Thank God. See, people that are in this class today, they are too different from Haba. Okay. Now, if it is aluminium, you extract aluminium by the same process of electrolysis. Using what? Concentrated what? Bauxite. You also have to treat that bauxite with what? Cryolites. You must treat in order to lower what? Melting what? Points. Let's go to number 2. Purification. I will end at number 2. Purification. Purification of metal. Purification of metal. Purification of metal. Now, in Anya, if you go with this thing, all those metals that are below carbon, below hydrogen, that you extract by other methods rather than electrolysis, they are not pure. I will repeat now. I said, all those metals. Now listen to me. You see those metals that you extract their ore. You extract the metal from their ore by electrolysis. The metals extracted by electrolysis, all metals extracted by electrolysis, sodium, potassium, calcium, magnesium, and aluminum. After extraction of those metal does not need purification. Purification is like second method of metallurgy. You know what I mean, metallurgy? Metallurgy is a commercial and economical process of extracting a metal from its ore. Are you with me? What do I say? Metallurgy. The commercial and what? And economical, or the profitable. Or again, profitable. Because somebody may get an ore cheap, or he didn't pay for it. After refining everything, he makes money. So you want to define it, don't say it's chemical. It's not chemical. It's what? Commercial and what? Economical process of what? Extracting metal from their what? Ores. That's metallurgy. Even in metallurgy, there were 5 principles that guides metallurgy. Write it down. 5 principles that guides metallurgy. Yeah, 5 principles that guides metallurgy, or metallurgical principle. Thank you for reminding me, because I don't forget them. Uncle, please, what is calcination? Okay, I'll tell you. What was the subheading there? 5 principles of what? That guides metallurgy, or metallurgical principles. Number one. Give me here. Mining. If you go to the metal, he was actually the metal. Mining. You get the thing in a mine. Mining of not the metal. Mining of what? Of what? Ore. 2 is what? Concentration. Concentration of what? Of ore. If you go through that short guide, on the last topic, the industrial chemistry, that's the last topic, biotechnology, you will see where these principles were listed, 5 of them. And when you now come to concentration, depending on the nature of the ore, there are ores you can concentrate by what? Calcination. Somebody asked me about calcination. You can concentrate by what? Roasting. Roasting in the what? In air. You can concentrate by what? By what? By leaching. Using Bayer's reagent. You can concentrate by frotting. You can even concentrate by washing. You can also concentrate by using aquaregia. Concentrating by what? Using what? Aquaregia. Aquaregia. Next one, what? Washing. If you know, this is a method of concentration. So all depends, the nature of the metal will tell you which method you are using. Aquaregia. Regia. Aqua now. Aqua Rafa. Aqua. Remember aquaregia? A mixture of HCl. Okay, now listen. Go washing. Only got assembly. Only is royal water. Royal water is aquaregia, a mixture of hydrochloric acid, a mixture of HCl and what? HNO3 is aquaregia. Any undissolvable substance dissolves in these 2 mixtures. You open a could dissolve. You will tear these 2 substances. It dissolves. Mixture of these 2 is what is called what? Aquaregia. This particular aquaregia specifically dissolves platinum and gold. Yes. Egia concentrated platinum and what? Gold. Specifically. Even platinum and gold are all reactive. So their impurities get from the metal. But if you dissolve it in this royal water, called aquaregia, it will dissolve the 2 metals and make the metal concentrated. Is aquaregia. Somebody say, what is calcination? Like, get it, like roasting in the air. It's not like roasting in the air. But this type is like when you heat the ore in the absence of what? Oxygen. You call it what? Calcination. For example, if you look at any ore that is carbonates, for example, limestone, of calcium, CaCO3. I want to change this ore to oxide. I told you that it is very difficult to extract ore. Well, let me just, okay. Thank God for you. I wanted to just say something and just go. Now, listen. This is ore, but this is a type of carbonate ore. Okay? I've said it times without number that if an ore is in carbonate form, the best ore to extract, the best ore that appears to be easily extracted is those of oxide. So many ores are changed to oxide by this process. Sure you know. If I want to change this ore to oxide, what I need to do is to heat it without oxygen. Just heat it without oxygen. It oxidizes to what? Calcium oxide. They release what? CO2. This is calcination. I can do it to dolomite. Dolomite is a double carbonate of what? Magnesium and calcium. I can calcinate dolomite. I will get two oxide ores very easily. Calcium oxide and magnesium what? Oxide. Very easily. I can calcinate zinc carbonate. I change zinc carbonate to what? To zinc oxide. If I change zinc sulfide to zinc oxide, which method have I used? Will I use here? Roasting in the air. I need oxygen so that this sulfur can react and go away. But if I have ZnCO3, I can't add oxygen to this again. What do? I leave it, put it in a blast furnace, cover it, heat it without oxygen. The process of heating to convert a non-oxide to an oxide ore is called what? Calcination. It's a type of concentrating carbonate what? Ores. In which categories? If I want to concentrate a sulfide ore, I use roasting in the air. If I want to concentrate a carbonate ore, I use what? Calcination. If I want to calcinate using leaching, I have to know that the impurities in that ore will be insoluble in sodium hydroxide. I now use what? Leaching. What is leaching? A process of treating ore using a Bayer's reagent. What is Bayer's reagent? Hot concentrated sodium hydroxide. Because I know that aluminum in the bauxite, being amphoteric, dissolve in sodium. Other impurities, being basic, will not what? Dissolve. So by doing so, all these impurities are now isolated, removed by what? Filtration. Will make the process what? Concentrated. So this particular leaching is basically used only for what? For concentrating what? Bauxites. This one is used to concentrate what? Carbonate ore. This one, sulfide ore. This one, bauxite. This one, sulfide ore as well, frothy. Sulfide ore. This one, platinum and gold. This one is basically for tin oxide. That is calcitrite. You get the calcitrite, all those sand in the calcitrite, you use heavy water. Heavy water, use heavy water. What's the form of heavy water? What's this? That is what? Deuterium what? Oxide. You use it, wash. Or use the water with so much power. Go pump your pressure and put that so that it can wash out those what? Impurities. I think I did John. I think I have to call it a